Hi, this is Junaid, neurocritical care stroke and epilepsy specialist, and today we're going to find out why AMD and Nvidia are at war. And we are starting to see the GPU war, which honestly is good for customers. But you need to understand why GPUs are important in terms of AI inference or AI training. And more importantly, if it were to you, what would you choose between AMD versus Nvidia? Let's find out. So we are really at the core of why GPUs are becoming so extremely important. It is probably one of the most important technology in terms of hardware that drives our software in terms of artificial intelligence is concerned. And there's only two big companies right now, right? The one is Nvidia and the other one is AMD. Nvidia came up with their Grasshopper super chip, and then AMD announced their MI300. We'll discuss both of them. We'll go through the whole video as far as what they have announced, and we're going to give you some live commentary as far as what this is concerned about. But before we do that, I think it's important for you to understand, like, why is it such a big thing? As a matter of fact, it is such a huge thing that within the last year to date, it's not even the whole year, Nvidia has jumped 200%. That's a huge jump, 200% in their valuation. This becomes one of the few companies that's $1 trillion company. And why? It tells you that artificial intelligence is going to be part and parcel of your future and mine, of course, and therefore you need to pay special attention about the digital transformation that we have been talking about in healthcare and everywhere else. And therefore, this is going to be key technology of our times. Now, before I start, people keep asking me, why are you so interested as a physician? Honestly, artificial intelligence really is so close to the brain itself. If you look at the neuron structure, we are looking at terminal axons. These are dendrites, and this is the axon. And if you look at how artificial neural network, ANN, this is artificial neural network, is designed, it is designed literally on the principles of a neuron. And therefore you have these, dendrites that are weighted, and then these weighted, actually there's normally a bias that you control the bias, and weights and bias are literally the two most important things that you have to know about. And then there's an output layer. And the way we are connecting one single cell body through dendrites to multiple different inputs, this is exactly how multiple neural networks are connected in hidden layer or full layer as far as that is concerned. And then there's, of course, the output layer that is concerned. So that is why, if you want to understand truly a brain, or if you want to create an artificial brain, this is what it is. But it tells you one more important thing. The synapses, this is synapses that are connecting from one neuron to another. It is so wide, it is so impressively parallelized that one particular neuron basically is seeing everything else, the whole brain. You have access to basically such a massive amount of connections. It's in trillions and trillions and trillions of connections that are going on. And that's what we are trying to replicate artificially. So why is GPU important? So again, one more important, this is embarrassingly parallel. Our human cognition is embarrassingly parallel. We are actually able to hold different concepts and then relate to them. We have visual input, we have audio input, we have tactile input, and we have our memory that we correlate to, and have a whole language system and a whole vision system. And literally transformers, which is one of our key technologies that is driving all the large language models, is literally based on this whole artificial neural network that is sophisticated enough now to be deployed at a scale that we want to. Again, scale is extremely important. We'll talk about this. So why not CPUs versus GPUs? That's the key thing. CPUs actually have multiple cores. Great. They could have 8 cores, even 16 cores. If you go to Xeon level processors, you are looking at, 18 cores or 28 cores, maybe, whatever. But GPUs, on the other hand, have hundreds of cores. Their basic architecture is superbly parallelized. Exactly what we need to mimic embarrassingly parallel tasks that we need for artificial neural network, interestingly, for human neural network. So therefore, GPUs are the part and parcel. They are the soul, the hardware, the brain that runs artificial intelligence, which is mimicked on the human neurons and the human brain. Now, one of the key things is this. Even the CPUs are concerned, they have what we call DRAM. So the whole CPU, there's a controller, there's a cache, and then there's a RAM, which is the random access memory, which gives you the information. And that actually goes into different ALUs, basically the processors, and they share one huge memory. Exactly, human beings share one huge memory. It's not like we are having swappable hard disks in our brain either. GPUs, all the GPUs, they're one controller, one cache, one controller, one cache, but they have access to one DRAM. Why is it important? I'm going to tell you. So GPUs have actually progressed from initially, right? I mean, if you go 10 years down the line, where were GPUs used? Let's see. Let's ask everyone. Like, simply, we were using GPUs for what? Gaming, graphics, right? That's why it's called graphics processing unit. But that graphics processing unit, in which you have to this octagonal that is used within the rendering of games, we found out that paralyzed, that super paralyzed, embarrassingly paralyzed compute is needed for artificial intelligence as well. And that gave birth to what we call GPGPU, general purpose graphic processing unit. That was where our main issue came in terms of understanding how you take this general purpose GPU that turns it into gaming, it turns it into AI. One of the examples that we're going to be using in our this is basically an AMD. I mean, I will come to what my personal preference is, but you don't have to understand. You don't have to use my personal biases. My job here is for you to understand this. So general purpose GPU structure, GPGPU can go into gaming. That is their gaming, and that's the RDNA architecture. And if it goes into artificial intelligence, that's a CDNA structure. And therefore, it's a compute optimized. And this is why we use it for artificial intelligence over here. And that is why you have real-time gaming, which is more optimized towards frames per second. And if you have this high-performance compute, flops per second is actually optimized for artificial intelligence. Again, their architecture and the base level is actually combined, and then optimization happens because both of them have hundreds of cores. And this is why AMD is actually EPYC, has a third Infinity architecture. This has a high bandwidth. Again, we'll come to memory, low latency, unified memory across CPU and GPU. Again, people think that a lot of inference tasks is actually happening on the GPU itself. Interestingly, AI inference is still mainly done on CPU. My computer vision model that we have developed and are going to be available soon. What they does is that it's reading brain hemorrhage, right? CT brain bleed. That is done totally. That inference is totally done on CPU. In terms of training, yeah, we can use GPU to speed up things. But at the end of the day, when the model is deployed, we deploy it at the CPU level because it's costless, it's easier to manage, etc., etc. But large language models are different. When you are coming from vision, from normally CNN, which is one of the ways that the architecture is, to the transformers, you really need inference to be also on GPUs because, again, it's embarrassingly parallel. That's the term you have to remember. Coherency and simplifies programming, and this is very important too, because when you have the architecture that is on one silicon, both CPU and GPU, you can assign tasks interestingly to both of them and get the most bang for your buck in terms of compute is concerned. And they have been working interestingly, AMD, from CDNA 1 to CDNA 2 to CDNA 3, which is the MI300, which honestly I'm very excited about. This unified memory APU architecture is extremely, extremely beneficial. Again, when you are deploying these, again, it is easy to make a chatbot on artificial intelligence with ChatGPT. It is very hard to actually deploy it for 1 million users. That's a different scale altogether. And therefore, you have to understand these things. People think, oh, wow, yeah, here's a YouTube video. This one person actually distributed it very easily. Yes, it is very easy on your own darn computer. But when you have to serve it to 1 million people, that's a different story altogether. Then you have to think about cloud cost, electricity cost. You have to think about, how much storage cost. I mean, physical storage space. Everything is needed. And that's where these things are very, very important as we move forward. They have the CPU and the GPU sharing RAM, and therefore this AMD Infinity architecture is actually more about unified memory as we go along. So that's what we think that is extremely important when we are developing modern architectures for machine learning. These are, of course, marketing material. This is about the software architecture. So they are using RCOM 5.0. And I'm going to come to this in a minute, and I will talk about this. Actually, let's just do it right now. So they have expanded support and access, this, all of that. Again, these are marketing materials. I don't need to go into this. They have a whole software stack that goes into it. The main question for me when I am actually thinking about, AMD versus Nvidia, and here's the crux of the matter. AMD's software stack is all open source. This is open source. AMD is complete. The software stack from top to bottom is open source. Does it matter too much? Not really. I mean, CUDA is not open source, so what? I mean, they're not going to be, basically, it comes with the hardware, right? It's not like they're closing it down for anyone. But it is definitely optimized for many different applications, and more so allowing about audio and video, and more so about, those kind of things as compared to where the gaming engine and everything is done. For me, if you're looking at large language models or radiology images, which is actually much simpler in terms of gaming is concerned, you can use either one of them. If I can use any one of them, then the question is, again, if you can't use it, you can't use it. You have to go with CUDA, and definitely CUDA is superb. I mean, there is really no comparison of what the amount of, the sophistication NVIDIA brings, both in terms of hardware and software, and how this vertical integration, and we have talked about it when we were talking about the importance of vertical integration, how Tesla is so successful, why Apple is so successful. That's exactly the formula that NVIDIA has used. However, now that I have a choice, the first thing is important thing is what? Always price, right? It doesn't matter. I mean, if I have to serve 1 million people and I have to look at $30,000 a month of a cost, I'm going to just look at the cost. It doesn't matter if it's NVIDIA or AMD. At the end of the day, that's the one thing, the cost. But then, the last, second most important thing, then it comes, if I do have the luxury of deciding that the cost is equal, everything is same, etc., etc., then always I will choose open source. No questions asked. I will always choose a stack that is open source. And one of the reasons that I've looked into this, that the open source stack is so important, is because of this. I mean, I don't know if you have read this article, Google, we have no moat, and neither does OpenAI. And one of the things that they're talking about is basically, this is, look, overlooking their shoulders, and they think that OpenAI has, taken the lead, and therefore we have to bring out Lambda and the whole, arms race between Google and Microsoft. Technically, OpenAI is very part and parcel of Microsoft. Technically, we aren't positioned to win the arms race, and neither is OpenAI. That is so important. Who's gonna win? The most important, the third faction, the most important faction is open source, and that's actually what freaking Meta did, right? I mean, Meta literally released Llama. And then once you had the Llama model, what ended up happening is every single person as an open source was experimenting with Llama. And their foundation model became the de facto model, and everyone was experimenting, and everyone was putting in results in terms of papers and everything. Half the papers I read in terms of fine-tuning, pre-tuning, in-context learning, everything freaking is coming from Llama. Not to mention, Llama is now officially Open Llama, which is 13 billion, is completely free now. So I can also use it for commercial availability. Make sure you follow me on Twitter and LinkedIn for these kind of news in terms of that is concerned. I am a true believer of open source. As a matter of fact, if you look through the Google and Microsoft and how Google came up with Microsoft, is a strong advocate for open source software, has contributed in many software projects, has a popular GitHub code repository, sees open source software as essential for innovation and collaboration. No doubt. I mean, and I'm going to show you some more examples. And then software, I mean, before Satya Nadella, that was different. After Satya Nadella, they actually completely changed their tune, and they opened up a lot of software to open source to bring in developers onto their platform by necessity, because they're losing the game with Google. They were losing the game with many other things. As a matter of fact, the whole open, Azure is built on Red Hat Linux. What is Red Hat Linux? Linux is truly open source software. You're building your whole company, Azure, as a huge arm of the company, which is cloud, is built on the Linux operating system, again, which is truly, truly open source. And if you look at it, how the models are coming, especially when you can deploy on AWS, the generative AI portions, you can see that Hugging Face. Hugging Face, if you don't know Hugging Face, first of all, you need to get out more. I'm just kidding. And then second law, Hugging Face is the largest. It's a 2 billion company that has bet on open source artificial intelligence. You go to their website, you can try, test, re-engineer, figure out what kind of open source models are there, and you can literally take them out and then readjust them for your own use. Therefore, again, companies like AWS are also preferring open source. Why? Because people like me would prefer open source, and therefore this community starts to grow, and therefore we want to make sure that neither Google or OpenAI has a moat, and we are actually, as users, are always in control of some technology as well. As far as AMD is concerned, as you can see, is also with Hugging Face. So AWS is Hugging Face, AMD is Hugging Face, and therefore they're actually talking to Hugging Face to make sure that their models are also specially tuned for AMD hardware. That actually changes the game a little bit more, because again, even if I'm a billion-dollar company, do I really need to make my own large language model? I'm going to fine-tune an open source model. That's what I'm going to do. And there are multiple open source models coming in as we speak and as we go around. So that was my small spiel. Now let's get back to this particular presentation so we understand what is really changing in terms of market is concerned.
Now, for those of you who are paying attention, you might see it looks very, very similar to MI300A, because basically we took 3 chiplets off and put 2 chiplets on, and we stacked more HBM3 memory.
This is Grasshopper. This processor is really quite amazing. There are several characteristics about it. This is the world's first accelerated computing processor that also has a giant memory.
But what you see with MI300X is...
Now, did you notice the minute they introduce either one of the chips, either it's AMD or Grasshopper, what did they talk about? Took out the chiplets, increased the memory. Grasshopper, it is the first accelerated computing in which better memory. Why is memory so important? And we'll come to that in a minute. And they're going to present it, actually, not me. So what I'm saying is that when you are looking at this, memory is becoming such a huge issue, because even the GPU cores, you can increase them, but if you're not going to give them memory, it's not important. The second biggest thing about our architecture is sharing the memory between the CPU and the GPU. And the third most important thing is everything is on one chip. So therefore, you can run inference on a CPU if you want, and if you want GPU, and if you want the same thing for training or inference, it can be used universally.
Combine CDNA3 with an industry-leading 192 gigabytes of HBM3 that delivers 5.2 terabytes per second of memory bandwidth, and it has 153 billion transistors across 12 5 nanometer and 6 nanometer chiplets.
It has almost 600 gigabytes of memory that's coherent between the CPU and the GPU. And so the GPU can reference the memory, the CPU can reference the memory, and any unnecessary copying back and forth could be avoided. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer, this is not a chip.
When you compare MI300X to the competition, MI300X offers 2.4 times more memory and 1.6 times more memory bandwidth. And with all of that additional memory capacity, we actually have an advantage for large language models because we can...
Memory. Because again, we have reached a limit of nanometers to decrease the wafer silicon. And I mean, the incremental performance and increase in terms of that is to a max. What we want to do now is adjust the architecture, share the memory with CPU, GPU, increase the memory. And most importantly, if you look at this large language model, generative AI space, you need darn so much memory because their models are becoming huge. And the more model you want to keep it within the memory rather than swamping files from the hard drive, then you can generate faster. So memory.
Capacity, we actually have an advantage for large language models because we can run larger models directly in memory. And what that does is for the largest models, it actually reduces the number of GPUs you need, significantly speeding up the performance, especially for inference, as well as reducing total cost of ownership.
Now, let me show you some of its performance. So I'm comparing here on 3 different applications. Vector database is a database that has tokenized, that has vectorized the data that you're trying to store. This is incredibly important for knowledge augmentation of the large language models to avoid hallucination. The second is deep learning recommender systems. This is how we get news and music and all the text that you see on your devices. Recommender system is the engine of the digital economy. This is probably the single most valuable piece of software that any of the companies in the world runs. And the last one is large language model inference.
So let's watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. All right,
Correct.
let's start. We have to give.
So the key issue over here is basically this. Vectorized databases. Again, if you have a huge database, I mean, let's just call it PubMed. I mean, it's 20 million articles. It's a huge database. Then you have to get this vectorized database. If you can bring it up in the memory in terms of speed, then those vectorized database can be easily available to this. One of the biggest issues that we face when we are delivering a product, especially in AI, large language model, or any other AI product, is latency. I mean, honestly, consumers are real crazy. I mean, they can't wait 4 seconds to get a response. And therefore, it is just annoying to see that these responses can be slow. And that's something we struggle with. I mean, my AI engineering team is constantly asking, is this okay? Is this fine? We have to optimize for speed and decreasing the latency. Why do we have to do that? It's because the consumers require this. It cannot sit there for 10 minutes for something to generate.
Watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. All right, let's start. We have to give the model a prompt. So we are here in San Francisco. Let's say, write a poem about San Francisco. Here we go, the poem's coming. You can see it's responding in real time. I'm not a great poet, I don't know about you guys. The city of dreams that always keeps you yearning for more.
Okay, this looks really simple, but this is exceptionally impressive. They took the Falcon 40B model, ran it in the RAM only. If I look at it, it just blows my mind. I mean, if I have to buy something, I would buy this, because then I can actually literally think of it that if there are 100 concurrent users, how many GPUs do I need to get? This is just beautiful in terms of demonstration that such a large language model, about 40 billion parameters, is being delivered, it's being deployed in just one GPU. Fantastic. And of course, it's not ever one GPU. You're actually always looking at, a cluster of GPUs. So I just wanted to make sure that that's one of the things. Again, I mean, I like AMD, it doesn't matter. You guys can do that, whatever you like. But again, if all things considered, I will always bet on open source, because open source is something that really can take it. And we have seen this over time. I mean, literally the rise of Google is one of the most important, demonstrations of how open access software is key to innovation and further innovations, especially people like me, where the companies are smaller here in US, and also serving globally, where actually the price parity, the ability of per person to actually match the pricing in US is much less, and therefore I have to deliver at a much lower cost. Open source over time always wins. Thank you.